Hello everyone, this is Amir from Audio Science Review. I've got a new episode for you. One of these trends that started in the last 2 or 3 years, maybe 4 years, is building audiophile switches, network switches. You get two reactions to that. Anybody in the computer space immediately says, yeah, that's a foolish thing. No way an Ethernet switch can make a difference. And then you have the audiophiles at the other extreme that say, oh, I'll put one in my system and made a night and day difference. And I don't know why, but it made a huge difference, so they must work. So, we could just argue with words, but it's always better to add some data to the discussions. And that's what I set out to do last year, and I think the year before that, with couple of kind members buying these products and sending them to me for both objective analysis and measurements, and also for with listening tests. So let's switch to that and start our discussion. First, let's start with the plain old Ethernet switch, gigabit switch. You can buy these 8-port ones for next to nothing, $20. If I built an empty box and shipped it to you, it costs more than $20. How these companies do it, manufacture something and send it out this cheap, I don't know. But regardless to say, the technology is heavily commoditized, and it has been for years and years and years. What is a network switch if you're not an IT or computer guy? It basically takes one Ethernet connection and gives you n number extra ones. So any port can communicate with any other port, and depending on the throughput, you can have concurrent connections going on. So at my desk, for example, I have one and lets me connect multiple multiple computers and audio products to one Ethernet jack in the wall. A key thing to understand about these products is that in a home application where the runs are very short, Ethernet switches are guaranteed to be reliable. There's no chance for the signal to degrade so much that you drop packets and what have you. And I've got a switch, 48-port switch that powers the entire house here. And once every few months, I look at the statistics, and it absolutely has zero data drops. Now, you could lose packets for other reasons. If you use Wi-Fi, you can lose a lot of packets. But when it comes to home wiring and the short wires that we use, this is just as guaranteed as you can get as far as reliability. Now, from a networking point of view, we actually have checks and balances on that, in that the standard protocol or communication language we use on top of Ethernet is called TCP/IP. And TCP is called Transmission Control Protocol, and its job is to provide a point-to-point communication, but also guarantee reliability. And what that means is that it'll send packets or chunks of data to the receiving system, and once in a while the receiving system will send what is called an acknowledgement back saying, hey, I got that range of data, you're good. And until it hears that, it actually holds on to the data. And if it never hears that message back, it will actually retransmit the packet. And the receiver then, if the data has been lost, it gets that back. There is another protocol called UDP that doesn't do that, but it's not a common protocol. So when you're browsing the web, the reason it's so reliable, despite so many computers and so many flaws that could happen, so many bad things that could happen to your packets across the internet, everything seems reliable, right? You're seeing me right now, and the texting or YouTube windows are all accurate and what have you. It's because of the power of TCP/IP. It was invented decades and decades ago, and is the foundation of internet. Because of that, if you take a server in your home and a client streaming player, network streamer, and you play content, you're guaranteed to get reliable transmission, either because Ethernet itself is so robust in a home environment, but also because TCP/IP on top of that will retransmit if needed. Now, if you use Wi-Fi, again, that's a different story. Wi-Fi is RF, and interference can cause issues there. TCP, again, tries to provide reliable communication, But if the data gets lost for long enough time, you'll get your playback will stop and restart. And but in no case, even in that scenario, does a fidelity reduce. You may get buffering where things start and stop. But because TCP is always robust and always retransmits, the final data that you get is very reliable. So naturally, nobody thought we needed anything better than that for audio. You know, when we're playing something from a NAS server, for example, or another computer that has your files on it, or from a streaming service on the web, once the bits, they're all bits, they're digital data that's coming. We're not dealing with analog transmission. So the common thinking is that once that's all the switch needs to do, it needs to get the data and get it to you and reliably through TCP/IP protocol. So why do we need a audiophile switch? Well, you know, what are these things supposed to do? The standard pitch for these products is that they want you to think that they reduce noise and jitter. These things make a lot of sense to a typical audiophile. They may not know what jitter is. They may not even know how noise gets generated, but they're intuitive concepts that noise must be bad and that jitter must be bad. And any device that reduces those two factors must be a good thing. Now, Ethernet, just like any other protocol, physical connection, physical transport, is subject to noise and is subject to jitter. But once it captures the data, the receiver, from then on, the data is digital. The concept of the jitter upstream is gone. There is no such concept anymore because you have digital bits. You can store them in a file. The file has no notion of a noise or jitter. It has basically thrown out whatever problem there was upstream. If you had too much jitter and you had too much noise, then the data would have gotten lost and you would have gotten a glitch and a dropout. Again, that happens with Wi-Fi, but not with Ethernet. So, but then, you know, then are we done? Do we just, you know, declare this, you know, open and shut case? Well, not quite. The moment you connect the Ethernet wire from a switch to a receiving, let's say, a streaming device, audio device, you now have a physical connection between the two. And in the theoretical world, if that source is noisy, because you now have this electrical connection, that noise can travel, in theory, to the receiver, and it can bleed into the sensitive parts of a streamer or a DAC and pollute its output. Now, Ethernet is designed to be robust against noise, so it has transformer and isolation anyway. But let's say that that stuff doesn't exist, that the cable just comes into the receiver and could inject noise and jitter. And that can happen in theory. There are ways, for example, if I take a DAC that's not well designed, hook it up to USB, the noise from USB can actually travel to the output of the DAC, even though bits are bits, digital data is reliable, yet noise can travel over ground wires and power wires into the DAC. So an audiophile that just has this rudimentary knowledge of how things work will automatically assume that there must be some merit to these things. So they go out and try to buy some of these products. And let's start with one of them that's quite popular in the forums and online. A company called Uptone Audio makes this product called Ether Region. It costs $640. And unlike our product that we were looking at that was 8 ports for $20, this one's only 4 ports and cost $640. So you could buy 30 of the other ones for one of these. So needless to say, it's not a economical solution. So it's got to do some magic. Now, this is an expensive product for them to actually build because they built their own switch from scratch. Although they use a SoC, a subsystem that already does some of this, they have built enough custom logic around it that if this did something useful, then you could sort of, convince yourself maybe it's worth it. Although this little hobby box is a giveaway that you're not buying luxury goods here. Going way down to where it implies that the fidelity is improved is that it's at the heart of this thing is this low jitter digital differential digital isolator chips and ultra low jitter differential reclocking flip-flops. Now, I know what these things mean, but I don't think you need to know what they mean. But an audiophile reading this just immediately thinks jitter is lowered. And if jitter is lowered, then must be that my noise floor is going down. And if my noise floor is gone down, maybe things sound more open, maybe with less jitter, things sound more analog-like, which audiophiles like to think analog is always better than digital. And they run off and purchase this and hook it up to their system. So as I said, we got one of these to evaluate, and I tested it. One of the key things here you want to know is that jitter and noise are extremely easy to measure. So when a company says, I've got product X, and it lowers jitter or noise, and they don't show you that the noise and the jitter are reduced, you can immediately write them off because they was either being incompetent or they don't even know if this thing reduces noise and jitter. Jitter is a variation in the clock, so designers know how to measure jitter, and we can even measure it with electronic audio devices, which I'll show you in a minute. So antenna is already up of, if this reduces noise and jitter, show me. If you don't show me, then Amir's going to go and test the claim. And that's what happened. So this is the box. As you see, it's got one port at one end, which is supposed to be its clean, ultra clean output. Then it's got the other side, which is sort of the dirty side. So you plug in your Ethernet in here that comes from your wall. And then it's the other side that's the uber clean. But there's also claim that these other ports, A ports, also do something. So I thought, well, okay, we measure everything. Now, one of the arguments about these devices is that if you go tell them they don't work, they say, well, how good is your system? Maybe your system's not resolving enough to see the difference that this makes. So I said, fine, for my testing, I'm going to use a streamer from a company called Matrix Audio, called Matrix I. It's a DAC with a streaming functionality built in, so it has an Ethernet port and Wi-Fi. It's a $1,000 DAC and streamer, so not cheap. It's not a $10 budget part. And it has exceptional performance. Not quite the max best of the best that a DAC can do, but extremely good, as I'll show you in a second. So I plugged this in and first tested the Matrix Element I with just my dirty wall Ethernet or cheap Ethernet switch that I have. And I'm actually streaming audio to it from Roon Media Player. So I'm simulating exactly what happens in real life. You have a Roon player or JRiver, what have you, UPnP, whatever protocol you're using, that's what I'm using. So I'm not using my audio precision to send data to it. I'm actually using a player on a computer, and I'm running Roon, and I'm pushing data to it, and the data is going over Ethernet switch, going to this element I, and spitting out analog output. So that's key. Remember, analog is what comes out of the streamer. There is no other output from a DAC, if you will. It's got audio. And that's the main thing that matters, is the audio, remember. So we look at SINAD, which I talked about before, is a sum of noise and distortion relative to our signal, is 113 dB, lower than our signal. This is at threshold of hearing, which means that this streamer is guaranteed to be transparent. Its distortions are below minus 120 dB. That's 5 dB better than our hearing threshold and dynamic range. So this streamer, what comes out of it is what's in your music. Something wrong with it is something wrong with your music. This device is not contributing anything to it. Despite using the dirty Ethernet gas going into it, is producing incredible performance. But maybe it gets better if we use ether region. First, let's start with port A, which is their semi-good ports, and run the exact same test. Do you see anything different? No, nothing's different. Even down to this little tick over here, minus 121 dB, no difference whatsoever. If there were jitter, it would show up around here. If there was noise, this would go up. Synad would reduce. This THD plus N would go up. Even the voltages are identical, 4.054, 4.053. Basically, if you breathe on this device, that little one-digit changes, but essentially there's no difference whatsoever on the A side of this switch. So let's go to the fancy port. Hey, let's go to port B. That's supposed to make the big difference. What do we see? Absolutely nothing. It's still 113 over here. Still a little better than minus 120. 4.05 volt, 1 kilohertz clock. Nothing has changed. Absolutely nothing has changed. And remember again, I'm measuring what comes out of the DAC and the streamer. This is all that matters because that's what you're going to listen to, right? The output of the streamer is going to go to your amplifier, go to your headphone or to a speaker system. That's what you listen to. You don't listen to Ethernet packets, right? We don't listen to digital data. We don't care what the black box doing upstream. Its job is to improve this if $640 is supposed to do that. And so far, $640 hasn't done us any good whatsoever compared to a $20 option. So let's talk about jitter. The device, as I said, claims to reduce jitter, but the jitter it's reducing is that of the Ethernet jitter. And as I said, the data is so reliable there, we don't need better clocks, but fine, we got that. It is possible to induce jitter in a DAC with just noise. So even though you're not mucking with this clock, we can run a test that'll tell us that jitter is nevertheless induced. And I won't talk about the details of it now. Maybe I'll do a video on that. But we can measure anything that's happening to that DAC chip that's inside of this streamer. That's done through a standard test we run called the J test. It's basically pure 12 kilohertz tone that we play. And then we look at the spectrum of anything around it. Okay, so this horizontal line is the noise floor of the DAC. And every one of these little ticks is basically an unwanted signal. Okay, notice the sensitivity of this test. It's at 160 dB below the 0, which is our signal. Remember I said threshold of audibility is 115. We're at 160. That's how deep we can go. We can go 30, 40 dB past the level that you can possibly ever hear. And when we look there, we see a little noise in here, a little spike in here, minus 140. This could be a power supply spike or something like that. And there's some other ones. What they are doesn't matter. What is important is that I've got the cheap switch, my $20 switch in blue. Then I've got the red one is the port B, the Uber port on this ether region. And look at this, the two graphs land on top of each other where you can't tell one from the other. Nothing has happened. These little ticks did not get reduced, did not get eliminated. We even have a little tiny bit of jitter. Jitter is always symmetrical. It shows up on both sides of our main tone. So there's a tiny bit of jitter at minus 140 dB. But did the ether region in red eliminate that? No. Look over here. It's still there. Made no difference whatsoever. All right, well, are we done? I said no. Let's first compare port A and port B on this thing, because they claim one is better than the other. Does port A and port B make a difference? No. So even on their own product, the one port that they say is dirtier than the other, they're both extremely good. They're both consistent with a $20 one. Now, people may say, well, there may be some RF and some ultrasonic noise that you're not showing because the previous test only goes up to 20 kilohertz. What if there's stuff above it? Now, never mind that we can't hear the stuff that's above our hearing range, but let's analyze that anyway. So we go ahead and run our J test, jitter test again, but this time I expand the bandwidth up to 95 kilohertz. So it's going way, way past our hearing range. There are some spurious tones in here, and I won't get into why they are here. But again, when I go through just a $20 no-name switch, and I go through this, absolutely no difference whatsoever. So nothing's been, even high-frequency noise is not being reduced in this. Somebody may say, well, that's not enough. Maybe there's this RF stuff that's getting in there. There's all this high frequency stuff that messes everything up in my audio. Again, remember, you don't hear RF. If you could hear RF, you go crazy because you hear the RF from your Wi-Fi and your cell phone and everything else. Thank God we can't hear RF. But hey, why don't we, actually, before I tell you that one, that's this test. Well, let me jump into this test and I'll go back. So I went ahead and increased the analysis spectrum to over 1 megahertz. And here, I'm just measuring noise. Okay, so I'm not streaming anything, but everything's connected. So if the switch, no-name switch, is injecting noise into my streamer DAC, then I should be able to see it. As you see in here, it makes no difference which port I use, whether I use my cheap one or whether I use the ether region. Nothing has changed. Not even a tiny, tiny, tiny hair has been moved. All the way up to 1 megahertz. Your speakers don't go up to 1 megahertz. Your headphone doesn't go up to 1 megahertz, not even remotely so. There's absolutely, absolutely nothing there. Now, if I don't go to 1 megahertz, which is this previous test, I can actually go to extremely low noise levels. So now I have juiced up my audio precision analyzer where it is now examining noise levels at minus 160 to minus 180. I mean, this is crazy. This is like us trying to hear noise on the other side of the planet. And here's the noise spectrum. No matter which switch you use, it makes no difference whatsoever. It just doesn't. No matter how we skin this cat, no matter whether we look at jitter, noise, distortion, nothing remotely has changed. As a side thing, this thing cooks. The mass market switch has been optimized to heck so that it's very power efficient. Touch the top of your switch, it will not be warm. This little guy's cooking. How long this $640 box is going to survive, I don't know. But it's also wasting this much power just sitting there cooking itself, doing nothing useful for you. Now people say, well, I hooked this up and I hear it. Why didn't you listen to it? Well, I listened to it. So even though everything in my body says, hey, this is not going to make a difference, hey, you got to be objective. I could have said none of this, I could have predicted all those measurements, but we still measure because we want to know. So I went ahead and set up an interesting test. Ethernet networking is what we call the asynchronous protocol. When you play audio, it's usually a synchronous protocol, meaning the host generates the packets and the DAC meters them out and is playing them in unison. Networking is designed to be to not care about timing. When a packet comes across from YouTube servers to your computer, you don't know. Indeed, on YouTube, you see a progress bar, usually is ahead of what you're watching, because it tries to pull all the data as fast as it can, just because, so that if there is a drop in throughput all of a sudden, it can ride that out and not get a pause and not get a glitch. So we can take advantage of that in that when we start to play something, the streamer is going to hoover all those bits and suck them in as much as it can and store them in its internal buffer and play. So even if we disconnect the Ethernet wire from it, it'll continue playing as if data is still coming. But one of the cool things is that when we disconnect the wire, we also disconnect the source of the noise and jitter, right? That's what these audiophile switches are supposed to do. So I ran such a test. I'm listening to the music with high quality, incredibly high quality DAC and a streamer and headphone system. And you could unplug and plug this Ethernet cable in as many times as you want. Nothing ever happens. Anybody who says these things do make a difference, they should get a loved one to do that unplugging and plug-in and have their backs be against it and raise their finger when they think there's been a switch. I guarantee you they will all fail. There's just no way you'll hear it. By the way, that also proves how robust TCP/IP is, that you can disconnect the physical cable and plug it back in 1 or 2 seconds later, and it recovers as if nothing had happened. It notices that the packets are getting lost, and it waits and waits, retransmits, and eventually it gets through. So both in listening tests and in objective measurements, none of this made a difference. Should it have made a difference? Well, no. Because anybody who designs a streamer that knows anything about good audio performance will know that this Ethernet data is coming in. It's going to be an Ethernet port. It's going to be a CPU. It's going to have an operating system. All of that are quite noisy. So a high-performance streamer keeps all that noise isolated from the DAC portion so that one noise doesn't bleed into the other one. So even if you had the world's noisiest Ethernet connection, the designers know that they should avoid letting that noise bleed into the DAC. Now, someone may say, well, maybe a cheap streamer would have this problem. My answer is, you're buying a $640 network switch to fix a cheap streamer? Once you get a good streamer, then you don't have this problem. And by the way, if that happens, why doesn't the manufacturer run the same test? Go ahead, find a cheap streamer and show me that there's an improvement. You won't be able to, because even in extreme cases, this is so isolated, so removed from where the business end of our system is, that it doesn't make a difference. So with respect to the switch, we've tested it, we've listened to it. It does nothing useful other than taking away $640 from you. Now, this is a little cottage industry now. Company after company has figured out, all I have to do is take some switch and change its power supply and change its clock and have a little story I write on a website, and I could also be in business selling a $20 switch for a few $100s or even a few $1,000s. Hey, I could do that. So a company called Silent Angel has a product called the N8. It's got 8 ports on it. And it's a revolutionary product, it says. Makes the music more musical and emotional. How do you make an Ethernet switch know that? To do that to your music packets? What is emotion when it comes to technical engineering? Is there a circuit inside this switch that says, oh, this packet of data is music and there's something wrong with it? I've got to make it more musical? So clearly this statement is nonsense. But it follows with what we've talked about, which is, lower electrical noise. And it, lowers interference. Remember again, all of this is upstream of our receiver. Once we get the data, we don't care about this. But hey, that's the story. And if you look down here, it's the standard story. Oh, better clock, so lower jitter, lower noise, less noise. Medical grade adapter, power supply. That must be a good thing. Well, somebody sent that one to me for testing also. So let's go look at that. This one is $400, a little bit cheaper. Not $640. It definitely looks like a generic switch. So they didn't even bother making a fancy switch for our $400. Fancy case. I'm not going to get into the details of this test, but you can, this is the standard switch again. Same story. Did it make a difference through this? Absolutely not. Everything is the same. Jitter test, identical. No difference whatsoever. Noise floor, clean as a whistle. No difference whatsoever. Now here I did another thing, which is, hey, let's generate a lot of traffic on the switch to make it busy so we can generate more noise and see if that pollutes the output of our DAC. It does not. Basically saturated a gigabit port, piping almost 700 megabits per second, which never happens in your home, continuously. No difference whether you use the cheap switch or their switch, makes no difference whatsoever. So I ran a test in here, interesting one. So I basically changing one to the other. Yeah, so I'm streaming through this new switch and I'm capturing the output and analyzing its distortion using the audio precision analyzer. I'm plotting that continuously as time goes by. Okay? While this is happening, remember I said that the streamer buffers a lot of data, so I can disconnect the cable and I can reconnect it, and things keep going. So indeed, I did that. At times, I'm not telling you, I did that. I unplugged the Ethernet cable, the streamer kept playing, and before I could complain and stop, I plug it back in. I disconnect it, plug it back in. You can see in here, down to 0.1 decimal place of noise and distortion, you cannot see any indication whatsoever that the cable was plugged in or wasn't. So if the Ethernet cable brings noise, then you should be able to see its effect. The fact that you can disconnect the cable and connect it, and absolutely nothing happens in the switch, means that it doesn't matter. Whatever noise and the jitter or whatever exists on Ethernet cable does not make its way all the way out to the output of the DAC. Listening test again. This time I did it differently. I did it the way an audiophile does. He's been using a regular cheap switch, goes buys this $400 switch, arrives all excited, plugs it in, and listens to it. And immediately notices an improvement. There's more detail, there's more air, everything sounds more analog-like. The veil's been removed. His system has never, ever sounded this good. Remarkable. Incredible. Guess what? When I listened, the exact same thing happened to me. I heard when I plugged in the N8, the fancy Ethernet switch, all those things happened to me. Yes, it did. But here's the catch. I went from listening to the audiophile switch and went to the cheap generic switch, and the same thing happened again. More air, more veil was removed. It was more analog-like. How is that possible? We just saw all these measurements and said that's not possible. Am I hearing an improvement? The reason is no. When you're paying attention to what your system is doing, your brain switches operations. It goes from lean back, enjoying music, to becoming an instrument. It's trying to analyze the signal. It's trying to determine whether there's more fidelity. When you focus, you start hearing the separation between notes. You start to see through with your ears the noise floor. You start to notice instruments, not because anything's changed, but because you are changing. You have changed. Turn yourself into an instrument, and you're now discovering things just because you have become different. The existing fidelity has not changed whatsoever. It's just like the Matrix movie where the kid, the spoon is bending and says it's not spoon that's bending, it's you that's bending. That's exactly what's happened here. So this is a pitfall for audiophiles who go buy tweaks of all kinds. No matter how implausible that tweak is, they perceive it improvement. And they do indeed hear it. But it's not the ear that's hearing it, it's the brain that's manufacturing that, because it's analyzing things in a different situation than the old system. So I listened, I heard what people hear, and I'm here to tell you it is not valid. Your listening tests have to be proper when differences become so small. You have to do a blind test. Get a loved one, put two switches next to each other, and unplug from one, plug into the other, and plug into the other one. Have the loved one do that 10 times and write down, your vote, which one's which. If you get more than 8 out of 10 right, you're golden. But I guarantee you have no prayer of telling the difference, because there is no difference. So, long video, but essentially the message here is very, very clear. These devices fundamentally cannot make a difference except for very, 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 very remote possibility. And that remote possibility maybe is with the junkiest DAC streamer you could ever come up with. And if such a product exists, why aren't they not showing it themselves? Again, anybody who tells you that they can reduce noise and jitter, Ask him for noise and jitter measurements. You see him in all my measurements. What's wrong with them? Ether Region, that company Uptone, swore up and down that they've done their own measurements and they will come up with it and will prove us all wrong. And that measurement, that review is a year old. Nothing came out. Nothing ever came out. They've made that promise many, many times. They're going to write a white paper. Where's the white paper? Where's the measurement? Nothing. All they talk about is if you look at the signal on Ethernet, how it's improved. And my answer to that is simple. I don't care how you improve the Ethernet signal. I don't listen to the Ethernet signal. That's a digital stream. I listen to the output of a DAC. And every test that I've shown you in here is measuring the performance, the analog waveform coming out of the DAC. That's all I care about. I don't care what's happening inside the soup. That's all those circuits inside. I care about what is the output of this DAC inside of a streamer. And if you don't improve that, you don't deserve a penny from it. Okay, hopefully that's been useful. I'll try to do more reviews and then sprinkle them here and there with these debunking videos, as people call them. Thanks for watching, and see you in the next video. Bye-bye.